Well, if you're sick of the jelly bean example, don't worry. We're going back to the cocaine example. We got two examples this whole section. We're just reusing the heck out of them. So remember that we had a table here that showed the treatment that recovering cocaine users were receiving and whether they relapsed or not. So same situation. We're going to talk more about conditional probability here. We did a little bit about it with proportions, and now we're going to talk about some actual probability rules that we can apply to more things. So if the person took the placebo, what's the probability that they relapsed? Remember how we approached that. If the person took the placebo, that means we are only looking at this data. We are ignoring everything else. We're only looking at the people who took the placebo. What's the probability that they relapsed? 20 out of 24. Not good. Okay? But that's how we do this, if you remember. 20 out of 24. We'll reduce it. Top and bottom are both divisible by 4. We'll get the probability is 5/6, about 87% or 83%, I think. Similarly, try this next one. Pause the video, see if you can answer B. Given that a person had lithium, what's the probability they did not relapse? Again, we're looking only at the lithium people. What's the probability of a lithium person relapsing? 18 out of 24. Also not great. All right. Which again reduced to 3/4 or 75%. So let's formalize this with conditional probability. Another way of being able to do this, another formula. For these tables, we can just use the tables like we did in the second video of this section. But for probability in general, there's another way. The probability of some event occurring, assuming a second event has already occurred, just like we were doing with the jelly beans, is conditional probability. And here's the formula. Again, this vertical bar means given or assuming. It's just their and probability, their joint probabilities, multiplication divided by the probability of that second one. So how does this work with this example? Find the probability that they did not relapse, assuming they had lithium. We use this formula. That's the probability of not relapsing and lithium divided by just the probability of the second one, lithium. If you don't like conditional probabilities, you can just use this formula and answer the question without conditional probabilities at all. Just a joint probability, multiplication sometimes, and lithium. So what's the probability that they didn't relapse and had lithium? Didn't relapse, had lithium. What's the joint probability? It's that overlap. There were 6 people out of 72. Okay. That's 6 out of 72 divided by the probability of lithium. 24 had lithium out of 72 total. And what you'll notice if you do all this out, you'll get something very familiar. The top divided by the bottom. Remember, division is the same as multiplying by the reciprocal. And then we get cancellation and we get 6 out of 24, just like before. So again, wait a minute. What just happened? Given that a person, did not relapse. So this should be 6 up here, sorry. Hopefully you were yelling at me and saying, Jason, you read the problem wrong. Should be not relapsing because these answers need to be the same. Yeah, so not relapsing giving lithium. That's the 6 out of 24. Okay, gosh. All right, there we go. So these answers match up just like we expected them to. And again, this formula, a lot of times this formula is going to be longer. But the thing is, you're not always going to be able to just look at the data and do it this way. Sometimes you're going to need this formula. Okay, we have some more examples of that in the extra practice after this one. So this does lead us to the mathematical definition of independence, a different one. If the probability of A given B is the same as probability of the first thing with no information, then they're independent. Let's take a moment to say that again. Two things are independent if the probability of something happening is the same as the probability of something happening assuming something else is already happening. If this assumption doesn't change anything, right? If this assumption doesn't change anything, then they're going to be independent. All right? So we can look at that. So given that a person relapsed, what's the probability they took the placebo? Another conditional probability one. But be very careful because this sentence is kind of phrased backwards. The given is always the B part. Kind of is a little unclear to see. But the given is always the second half. It's A given B. Okay? A given B. So here, the given is the relapsed part, right? Given that a person relapsed, what's the probability they took the placebo? Well, we'll use a formula, probability of placebo and relapse over the probability of just relapse. Or you could do it with conditional probability way. Given relapsed, what's the probability of placebo? Given relapse means we only look at these. What's the probability of placebo out of these ones? 20 out of 48. Okay, two ways getting to the same place. Try using this method. You'll see that you get the same one. Everything here is divisible by 4. We get 5/12 as our probability. So letter D asks, is treatment and whether they relapsed independent? Well, they're independent if the probability of anything, well, there's a lot of things that you can check here. The probability of some kind of treatment and relapsing or not, are those independent? You could look at any combination here. So we just found this, so let's just use this again. Is the probability of placebo, assuming relapsed, is that just equal to the probability of a placebo? Well, we just showed that the thing on the left is 5/12. The probability of a placebo, the probability a randomly selected person got a placebo, is 1/3, 24 out of 72. Those aren't the same. Okay? They are not the same. So no, not independent. Now, in reality, most things aren't going to be perfectly equal in the mathematical world. Okay? 1/3 is 4 out of 12. 4 out of 12 and 5 out of 12 aren't crazily different. Is that significant? That's a question we ask later on in this class in Unit 8. Because really, nothing's really going to ever be equal in reality. Okay? We just have to talk about, is the difference big enough? We talk about that with hypothesis testing. But for now, this is just practice using the definitions. This is how you can use the definitions and the formulas for conditional probability. Let me know if you have any questions about any of this. Bye-bye.